So today we are going to continue with the basics of algebra chapter. Okay, and we will see how
Ma'am,
we do. Yes,
discuss the test paper now.
I'll discuss the test paper. Okay, once we're done with this chapter, I'll keep a separate class for
Ma'am, when is it, ma'am?
I think probably next week. Okay, we
Next
will
week when?
discuss the test Monday or Tuesday. Okay. We will discuss the test paper and I'll take your queries from exercise 9.4 to 9.6 if there's any query. I will take that also. Okay. And I will discuss this previous test and where the improvements are needed. Okay. I'll be discussing it, but right now we are going to start this.
Um,
Yes,
did, isn't this algebra chapter already done?
Yes, Amin, it's done for you. And but for Edric, Anaya, and Abraham, it's not done because it's joined a bit late now. So I'm giving a quick backup. Okay, so you can revise it.
Ma'am, for me, the algebra chapter is done, ma'am. For me.
For you, it's done. Okay. When did you join, Edric?
Ma'am, I joined in May.
You joined in May. Okay. In which chapter?
Algebra chapter.
Okay, so you joined in this chapter only. Okay. All right. No problem. You guys can revise this. Okay. You guys can revise the chapter. And if there's any doubt, Anaya and Abraham can ask me. Okay? Yes. So let's begin. Addition.
The same background.
Hi, Anaya. Good afternoon. Okay.
Good afternoon. Ma'am, I have a question.
Yes, Anaya.
The homework you gave yesterday for the 9.6 index questions, you said it's in that, right?
What question, Anaya?
The when compound interest minus simple interest is rupees 549, the rate is 20% and the time is 9 months. I was not able to solve that, so if you could tell us how to solve it. I wasn't able to solve it. I was trying it, but I wasn't able to.
Okay. Were the rest of you are able to solve it? Edric, have you done it? Are the rest of you able to solve that question? Can you give me the figures now?
Sorry?
Can you let me know the figures
What?
for that question?
Yeah. So we have to solve the what do you call it? Yeah, the compound interest minus the simple interest is given, which is 549. The rate is 20%. Time is 9 months. And we have to find out the principal in this. It's compounded quarterly.
Okay. Okay, so first let's calculate the time. Okay, in this question, time is given to us 9 months. So when we are given in months, what do we do actually?
0.75, ma'am.
Yes, 0.7.
Ma'am,
Yes.
I'm just write 3. Decimals are too complicated.
Yeah, so later on you're gonna write 3 only. No, ma'am, 0.75 into 4.
Yes, because it's compounded quarterly, we will multiply it. There's 4, we will get 3. Okay, so time will be 3. Now, the formula difference equals to principal inside the bracket rate by 4 by 100 raised to the power n.
How
Okay.
do we know when
4n.
it's rate by 4 and
4n.
when it's not?
Yes, 4n. Yes, Daniel, tell me. What's your
How do we
question?
know when it's rate by 4 by 100?
Rate by 4 by 100 because the question is telling you that it is compounded quarterly. So like I explained in the form when I was explaining the formulas, when something is compounded quarterly, you divide the rate by 4, okay, and
So,
multiply the
always
time
when it's
with,
quarterly.
yes, yes, Tanvi. When it's half
When it's
yearly,
quarterly
we
and half
divide the
yearly,
rate by 2. Yes, yes.
half yearly will be divided by 2.
Yes, half yearly we divide by 2. And if it's annually, we don't divide it with anything. Then as it is, we take it. Okay. Then difference is 549. So put 549 here equals to principal. We don't know. So as it is. Rate is how much? 20 by 4. So it
5.
becomes 5. 5 by 100. Okay. And our power becomes 3. Raised to the power 3. Okay, then
Ma'am, will we do this minus 1? Will we minus this by 1? 5 by 100?
5 by 100, you can write this as 1 by 20. Okay, you can cancel it.
Ma'am, once we have see the bracket inside the bracket, the r by 4 by 100. Once we have added this with 1, will be um, multiply itself into 3 and then minus it by 1?
Multiply it with 3 and minus by 1. Um,
No, will we will we take 21 by 20 raised to the power 3 and then minus 1?
okay, the formula that is T 1 plus 5 by 100 raised to the power 3. That's what you're asking, right?
Yeah, and then minus it by 1. The answer you get after raising it to the power 3, will you minus it by 1?
105 by 100 minus 1.
No, ma'am, you will first raise it to the power 3, and then the answer you get it, you will minus it by the denominator, minus 1.
Try to solve this in this way and see what you are getting.
No, I was asking, ma'am, because the other questions we had to do it like this, no?
Who clears the screen? The other questions where I teach you, I haven't used the 1 plus. I haven't used it at all. I have just the formula that I showed you, the difference formula. Can you check once and tell me the difference formula that I teached you before?
Ma'am, I know, ma'am. It's
Yes,
P
Ajay.
into R by 100 to the power of N.
Yes, R by 100 to the power of N. This
Ma'am,
formula, yes,
but it's quarterly. So R by 4 and 4N.
yes. So, Anaya, when we are having the difference in compound interest and simple interest, this is the formula that we use, okay? It doesn't has plus one in it. So you don't have to do minus
Okay.
one. Okay, so you don't have to do minus one. This is the formula that I showed you when we were doing the exercise 9.6. Okay, this is how we do it. Please don't clear the screen. So it will be 549 equals to who's clearing the screen? Please don't do it. T, then R is my 500.
Which question is this?
This is the last question from the test that I just sent.
The last question.
Yes,
Ma'am,
the last.
Ma'am, someone's raising it again and again. I'm not able to copy it down. Could you please ask them to
ma'am, it's
stop?
Abraham, ma'am.
Just give me 1 minute.
Edric, I wasn't touching the keyboard at all. I'm not touching the computer at all. It wasn't me.
Okay, so
Ma'am,
difference. Yes,
how come now you changed it from whiteboard to screen?
I changed it.
Because
to
in whiteboard, nobody else can do anything.
No, ma'am, in screen nobody else can do anything. In whiteboard you can erase. In screen you can't erase.
raised to the power 4m. So difference we have 549 equals to principal. We don't know. Rate 20 by 4 I did. So 5 by 100 raised to
Three,
the
three,
power.
three.
So 549 equals to principal into this I can cancel 1 by
1 by
20.
20.
So 1 by 20 into 1 by 20 into 1 by okay. So 549.
Ma'am, we get P by 8,000.
Yes, P by 8,000. Now solve this and tell me what are you getting next.
Equals to 8,000 to 549. Is that it, ma'am?
Yes, ma'am.
Um,
Two, two.
Ma'am, the answer is 439,200.
0.
Yes. Okay. So this is how we solve it when the difference is given to us and we have to find the principal. Okay. You don't use 1 plus r by 100. Okay. You don't use 1 plus. You just use the rate. Okay. By 100 and the power. If it's half-yearly, divide by 2. If it's quarterly, you divide by 4. Okay. Divide the rate
Ma'am.
into 1, 4. Yes.
Ma'am, I don't think it's that much. I think it's only Ma'am, how is P so huge? How is P
Yeah,
so
how can it become so huge?
Even I don't know
It's like
how
4
it,
million. 4 million.
I don't know how P is so huge. Maybe there's some mistake with the figures because the method is the same. Like if you solve the other questions with this method, when we did 3.6 with this method, we were getting the answers. 3.6.
Because every time I solve something like this, sometimes it comes as a big number also, and my mother is like, how is that even possible?
Mm-hmm. That happens. Yes, that's right, Sonia. And it might happen. Sometimes it comes as bigger numbers. Sometimes there is some misprint in the question only. We don't know how. Sometimes there are like some misprints in the book. So that's right.
Ma'am?
Anyways, having yes.
And how come the difference is so less and P is so huge? It's so huge.
No idea how the difference is so less.
I thought difference will be at least 10,000 for for this big of a P.
Yeah, it's 43,92,000.
Mm-hmm. That's right. So
4.39 million.
maybe there's some misprint in the P or in some other rate or something to know about it. Anyways, whenever you have such a question, this method will be the same. Okay, the method that we're going to use, this formula, it remains the same for this type of questions. Okay, so shall I use it now?
Yes, ma'am.
Okay, ma'am.
Okay. Yes, so Simeon, I hope you know that this question I gave bonus marks in the test. 3 bonus marks I gave for this question.
Yes, you said yesterday in the video.
Yes, because this question was um
Question 7, part
uh,
3 was wrong.
Yeah, you had said that CI was 549.
yes, I said CR was 5.9. It was the
But it was
difference.
CI minus SI.
Yeah, yes. Okay. So now we will continue with the algebraic operations. Let's see addition first. Okay. I hope it's clear here in the notes. Now, when we are doing addition of a variable and a number, okay, we just write it like that. Suppose I have a statement, add 4 to x. So what will be my expression? X plus 4. Okay. Or if my statement is add y to a. So it will be a plus y. Okay. So in addition, we just like it's just like the normal addition. Okay. We just put a plus sign and write a number with a variable or a variable with a number. Okay. Then similarly, it's with subtraction.
Ma'am,
Similarly, yes.
how come when we add two numbers, for example, like 3 plus 5, it is 8. And how come for here it is x plus 4? Then what should we write? Is it the answer just x plus 4? Or
If we only have the information till add 4 to x, the answer will be x plus 4. Okay. Until you have a complete linear equation, okay, until you have a complete equation, this will be considered as your answer, okay, until you have a complete statement, all right. So right now we are learning how to form statements, how to operate with the all 4 of them, and like In the next class, I'll show you how to actually solve these. Okay, the solving part. So, in subtraction, suppose I'm having a statement 3 less than y, less than y.
Y minus 3.
Yes, y minus 3. Okay, or if I have subtract variable y from x. Subtract variable y from x.
Ma'am, it is
So
X minus Y.
yes, x minus y. So until you don't have the complete information of the equation, this will be considered your answer. Okay, like this we do. Now homework for this class is read page 69 and 70. Okay, then more examples are there, some illustrations are there, okay, which want you all to give a read. Okay, read page 69 and 70. Okay, now multiplication. Very simple and basic. Just like I always explain, you write the number and variable together. Write the number and variable together. Okay. So when we are multiplying in algebra, we don't put multiplication sign, okay? We don't put an x sign, multiplication sign. We just write them together. So that's understandable that multiplication is there. Okay. For example, 3 times x. 3 times x. So I will not write 3 into x. I can directly write 3x. Okay, so where I've written 3x, it's understandable for me that it is 3 into x. Okay, or suppose if I have 5 times t, 5 times t. So I don't have to write 5 into t. I can just write 5t. Okay, so that shows me that 5 and t are in multiplication.
But ma'am, you can't apply this thing if it's
To the
only in
numbers.
numbers or if it's an only variable, right,
Yes.
ma'am?
Yes, yes. If it's only variable, you can apply this, but if it is only numbers, you cannot apply this.
You have to multiply.
Yes, yes, you have to multiply them. If I have 3 times 4, so you cannot write 34. Okay, you have to write this will be
12.
wrong. 3 into 4 we will do, that is 12.
12.
Okay. Yes, but if we have x times y,
XY.
so that if we have both variable, we can write it as x, y. Okay. But only numbers, we cannot write them together. We have to multiply and then write the answer. But if in the case of variable, or when we have a number and a variable, or a variable and a number, we put them together and write it. Okay. Hope it is clear till here.
Yes, ma'am.
Everyone, Abraham, Sunil, is it clear?
Yes.
Okay. Abraham, am I audible to you?
Yes, ma'am.
Okay. So let's see for division now. Now what happens in division?
Ma'am, do we write the division sign or write by, upon?
We do upon, okay? In most cases, we do upon. Suppose I'm having x divided by 6, divided by 6. So I can write it like x by 6.
X by 6, x upon 6.
Yes, x upon 6. Or if I'm having x divided by y divided by y. So I can write it like this, x upon y. Okay, you can write it in upon. Okay, this is what happens in division. All right, now one thing we're going to see. I'm erasing the multiplication part. Okay. So we will talk about terms and coefficients.
Terms and conditions apply.
Not terms and conditions, terms and coefficients. Okay. So
Ma'am, have you written efficient or efficient?
efficient. Efficient. Okay. So yes. Now example. Let's take one example. Three x plus 5y minus 9. Okay. Now
X plus 5y minus 9.
minus 9. So what is my term in this?
3x, 5y, and 9.
Yes. So 3x, okay, is my first term. Okay. 5y is my second term. And 9 is my third term. Okay, so what is a term? It is a combination or product or division of a number and a variable or numbers and variable. Okay, it's a combination of, it can be numbers and variables. Okay, and what separates the term? Signs separate a
Plus and
term.
minus.
Yes, plus
Ma'am?
and minus.
Ma'am?
Yes.
See, so if the expression is 3 into x plus 5 into y minus 9, then what are the terms?
5x,
3x, 3 into
3x,
x,
and what was the last one?
3 into x plus 5 into y minus 9. 3 into
Yes.
x is one term,
So
5 into y.
all the and 9 is the last one. Yes.
Ma'am?
So every part, okay, every number and a variable, 1 second, which a sign separates, okay. This is separated by a sign. This is separated by minus sign, and this is also separated by minus sign.
Ma'am?
So they are all, yes, terms.
Ma'am, they're only separated by plus and minus, not by into and divide.
Yes, terms are separated by addition and subtraction signs. Okay, And what's a coefficient? Combination.
You said coefficient yesterday, right?
Yes, I explained it yesterday, and I'll just give a little recap today. Combination of product or division of a number and variable are terms. Okay. So in my definition, it's written combination of product or division. So what does it mean? Combination of a product or division. 3x. If I look at it, it's a combination of a product, that is 3 into x. Okay, which is separated by an addition sign. 5y is a combination of 5 into y. Okay, so those are my terms. Okay, if it was like this, x upon 3 plus x upon 5 minus 9. Now this is in division. X upon 3 means x divided by 3. Okay, plus x upon 5 means x divided by 5. This is the definition of term. You can write it down. And what does it mean that I'm explaining? Okay, so minus 9. So this is a combination of division and this is a combination of product, which are separated by addition and subtraction signs are known as terms. Okay, are known as terms. Now, coefficients, like I explained yesterday, are what? Who's gonna tell me?
Ma'am,
Yes.
ma'am, the multiplier of a variable, the multiplier or the dividend divisor of a variable is called coefficient. The number.
Yes. So coefficients are the multiple of variable. Okay. Multiples
Multiple
of the variable.
multiple slash dividend slash divisor.
Yes. Okay. So of the variable. Now in this example, what is my coefficient of x, 3 and 5 are my coefficient. Okay, 5 is the coefficient of y and 3 is the coefficient of x. Okay. Constant, I have one constant, that is 9. One constant I have, that is 9. Okay. And terms are 3x, 5y, and 9. So I have terms, I have coefficients, I have constants, and what are my variables? Variables are x and y. Okay. X and y are my variables. Okay. So these are my terms and variables. One more thing I want to explain to you. Okay. One more thing. Look here. I'm going to write some things. Okay. Some terms.
X to x.
Okay. Now, can one of you tell me what is common in all of them?
Ma'am, x is common factor.
X is the common variable. Okay, they have common variable x. They all have x as common variable. Therefore, they are called like terms. Okay, so these are all known as like terms. Like terms. Those terms which have only one kind of variable. If it is x, all the terms will have only x. Okay, if it is y, all the terms will have only y as the variable. Okay, y by 3, 3y, okay, or only y. So that will be like terms. Okay, suppose in this equation I have, let's create one equation. 2x plus x minus x by 2. Okay,
2x plus x
minus x by 2. Okay, so this is all like terms. Okay, these are known as like terms. Okay, now let's see one more. Just a minute. Yeah. So now I'm having 2t, comma 3y, comma 4x, comma 6ab. Okay, 2t, 3y, 4x, and 6ab. So how many variables I'm having? How many variables I'm having? Different kinds of variables I'm having.
Ma'am, 5 variables you have.
5 variables. T, Y, X, A also, and B. So they are all different. Okay. They all are different variables. Are different variables. Hence, these are unlike terms. Okay. Hence, they will be called unlike terms. Okay. Unlike terms. Here also in this equation, 3x plus 5y, it is unlike terms. Okay. I'm having 3 terms and 3x and 5y are unlike terms because they have different variables. So they are unlike terms. Okay. They're the same variable, same like terms, and different variable, unlike terms. Okay. I hope it's clear till here.
Ma'am? Yes, ma'am.
Okay.
Ma'am,
All
time
right.
up.
Okay. So one thing more we will see.
Ma'am, it's time up. Tomorrow do it.
I know it's time up, but we started the class a bit late because of the whiteboard issues. So this small topic I want to cover
Okay, so
it
then
up.
finish at 3:45 then.
I'm noting the time entry, okay? And I need you to focus on what I'm teaching, okay? Yeah. So now I'm going to tell you some operations, okay? Like some sentences that are mentioning the operations. You guys have to tell me how do we write it in equation form, okay? Suppose it's add two variables p and q. Add two variables p and q. So simply, like I taught before,
P
in the
and
example,
what?
p and q, Simran, p and q. So I can write it just like p plus q. Okay. Suppose I'm having another one. Subtract 2 from Z. Subtract 2 from Z. So I can write it as Z minus 2. Okay. Then add 3 to the product of 7 and Z. Add 3 to the product of 7 and Z. So first we have to do the product of 7 and Z. That is 7 into Z plus 3, which becomes 7Z plus 3. Okay, like this. So this is very simple. You just read the sentence carefully, analyze, and then do the write the equation in the form of an operation. Okay. If it is addition, we can write it in the form of addition. Subtraction, then in the form of subtraction. If it is multiplication, then in the form of multiply. If it is divide, then in the form of divide. Okay. So just like that, you guys can write. So I want you all to revise it. The homework is revised till here. Do the exercises, I think till 4.2. Okay. Do till 4.2 and give this a read. Okay, and we stop here. That's all for the math class today.
Thank you, ma'am, for stopping here.
See you tomorrow. Bye.
Bye, ma'am.
Bye.
For the science class is right now. A couple minutes break, okay? And then we
Okay,
will
thank
start. Yes. Sunil, as per your question, we're having the science test tomorrow. Okay. We are having the science test tomorrow.
Okay. Did you send any pictures also of a diagram to draw this time?
Oh, I'll so sorry, Sunil. I'll share it today itself. Okay.
Okay.
Yeah, I'll share it in the group today.
Okay, thank you.
Thank you. Hello. Hope you guys are there. We are going to start with the science class right now. Can I have your camera on, please? You can have in a minute. Turn on your videos, please. Today we are going to start with this topic known as propagation of heat. Okay. What's the meaning of propagation? What does it mean? It means to spread. Okay. To spread, like the spreading of something. So, what does it mean with propagation of heat, spreading of heat? What does it mean? So, now we'll talk about it and we will see that what does it actually means. Okay. So, suppose I have a metallic rod here. Okay. A metallic rod here. And this is one end of it. And I'm heating it from this end. Okay. This is fire. And I'm heating it from this end. Okay. Now, slowly, what happens when you're constantly heating it, that the heat, it starts getting heated up from this end also. Okay. Why? Because heat is moving from here to here. Okay. Heat is moving from the end on which is it's heated up to the another end, which is there, which doesn't has which is not on flame. Okay. So it's um heating up to that side. Okay. What's happening? It's spreading the heat. Okay, the heat is spreading. All right. So this is known as propagation of heat. Okay. This process is known as propagation of heat. Okay. Keeping the hot tea filled mug for some time, the tea cools down. Okay. But have you noticed that when we pour hot tea or something hot in a cup, that cup also starts getting hot? Okay, it becomes hot. Why? Because there is propagation of heat. Okay, there is spreading of heat. Suppose there is us. Okay, we are standing or sitting in front of a bonfire. Okay, like out of cold we came and we just sat in front of a fireplace. So slowly, our body will start becoming warm. Okay, our legs start feeling, the legs become warm first. We start feeling the warmth in our legs. Okay. How? Like, why? Because heat is moving from one object to the another. Okay, like heat is traveling. So that is called propagation of heat. These actions show that the heat flows from one object to another, from one place to another, and from one part of the object to another. Yes, Sabine.
I I learned about the same thing, but it was in a different textbook, and in that textbook it didn't say propagation of heat. It said some law of thermodynamics.
Okay, some law of thermodynamics.
Yeah, and the
Also,
law was that when two objects are making physical contact with each other, they
Is it
their
the zeroth
temperature,
law of thermodynamics?
huh?
When is it the zeroth law of thermodynamics? The
No, the
zeroth law.
first law.
The first law.
which law again?
The
First
first
law of
thermodynamics.
thermodynamics.
The first law of thermodynamics. Okay, all right. Okay, so now the process of transfer or displacement of heat is called propagation of heat. Okay, when the heat is transferred or when it's being displaced, it's known as propagation of heat. How does heat propagate? Let's understand. So this is an activity where they've taken two rectangular pieces of iron or any metal of the same size. They heated up one of it, okay, one piece. Now they placed the second piece of iron or any metal close to it either or on top of it. Okay, so after some time, that like they measured the temperature of the second piece before placing it near to the piece which is heated up. Okay, and then after placing it on top of it or very close to it, its temperature will increase. Okay, its temperature will increase. The propagation of heat between two objects is due to temperature difference. The heat always flows from a hotter object to a colder object. Like I explained previously, heat hotter object, and here is the colder object. So heat always flows from a hotter object towards a colder object. Okay, like these are
That's the first law of thermodynamics. Whenever a
yes.
heat passes through
Mhm.
the colder object from the hotter object, it's the first law of thermodynamics.
Okay, that's right. All right. So you can try out activities 10.3 and 10.4. Good, Anaya and Supriya. And 10.5. Okay. Convection. It's talking about when we come out in the sun, we feel warm. How does the heat from the sun reaches us? It cannot reach us by conduction or convection because both of these processes require a medium. There is no medium, such as air, in most part of the space between Earth and the Sun. Hence, from the Sun, the heat comes to us by another process, which is known as radiation. The transfer of heat by radiation does not require any medium. Okay, it does not require any medium for the heat to get to us. Okay. Um, when we sit in front of a room heater, we get heat by this process only. Okay. Sitting in front of a room heater, we get the heat by the process of radiation. Okay. Our body too gives heat to the surroundings and receives heat from it by radiation. A hot utensil kept away from the flame cools down as it transfers heat to the surrounding by radiation. It means that all hot bodies radiate heat. When this heat falls on some object, a part of it is absorbed and a part of it is reflected. Okay. When the heat falls on some object, okay, a part of it is absorbed here and a part of it is reflected. Okay. Then the temperature of the object increases due to the absorbed part of the heat. Okay. So here it will absorb. So temperature will increase of the object because of the heat it has absorbed. Okay. Now this is land breeze and sea breeze. I know that you guys have heard about it previously. Must have heard about it. Can anybody tell me what happened in this phenomenon in this process?
Ma'am, in land breeze and sea breeze, land breeze is always hot because or like the land breeze is always hot and the sea breeze is always cold. In the day, the land breeze is the one that's active, and at the night the sea breeze comes over and takes the place from of the land breeze, and the land breeze rises up. It's like that.
Mhm. Very good. Good, Amana. Anyone else? Yes, Ibrahim.
Actually, mistakenly unmuted.
Mistaken my mute. No problem. Yes, so just like Anaya explained, during the day, the land gets heated faster than the water, okay, because of the radiation from the sun. Because of the sun rays directly falling on the land, it becomes hotter, okay? And then the land base is also hot, okay? So now what happens? The air over the land becomes hotter and it rises up, okay? The air from here, it rises up, okay? And the cooler air from the sea takes its place. Okay, takes the place of the hot air. Cooler air from the sea. This is a sea breeze. It takes its place. Okay, of the warm breeze.
One of my
Then
friends, his house is on a beach.
okay, and what have you observed?
I didn't go there.
You didn't go there. Okay, so if you go there, you can observe. Okay, you can
Yeah,
observe
but
this
we used to
phenomenon.
live near the sea, two
Okay,
kilometers from there, and there used to be a lot of wind. And whenever we hang out our clothes to dry, it'll all get blown away.
okay, that's right. There's high pressure of wind near the sea. There's a lot of wind. Absolutely, yes. Okay. At night, the land cools down more quickly than seawater. So cool air from the land moves towards the sea. Okay. This is known as land breeze. This is the night phenomenon. Now land cools down more quickly at night. So the cool air from the land, this is cool air, it moves to the sea. And warm air here from here rises up. Okay. So this is a phenomenon of land breeze and sea breeze that happens um, through heating process. Okay. Through the process of their heating up and cooling down. Now, properties of clothes we wear in summer and winter. In summer, we prefer light colored clothes, and in winter, we usually wear dark colored clothes. Um, can anybody tell me why do we do this?
Ma'am, because dark color clothes absorb heat. So if we wear dark color clothes in summer, we'll get too hot. And like we feel warmer when we wear dark colored clothes in the winter.
Yes, that's right, Mohammed. Good. So in winter, we use woolen clothes. Wool is a poor conductor of heat. Moreover, there is air trapped between the wool fibers. The air prevents the flow of heat from our body to the cool surroundings, so we feel warm. Okay, like air doesn't pass through them. Okay, and heat also. Okay, heat also doesn't pass through when we are wearing warm clothes. Okay, so they keep us warm. Okay, and light color clothes. And when we are wearing light color clothes in summers, air passes through it. Okay, and heat also. Okay, and heat passes through and it's replaced with the cold. So it keeps and they are lightweight so that we don't feel hot in summers. Okay. So you can try out these activities with the cans. Okay. And index questions 10.2 is the homework. Okay, try them out. Next, we will talk about combustion process. Okay. Anybody knows what does it mean? Combustion process. No? Okay. So basically, this is a process that's related with burning. Okay. And it is a chemical process. Okay. It happens chemically, like it's a chemical process. So the process of burning is known as combustion, and it is a chemical process. And why it is a chemical process? Because a reaction is taking place in it. Okay, because a reaction is taking place in it. How? In this process, a substance reacts with oxygen to give off heat. Okay, a substance reacts with oxygen to give heat. This is the combustion reaction that's taking place. The substance that undergoes combustion is called a fuel. Okay, that undergoes combustion is called a fuel. Some materials burn with flame like a candle, while some materials burn without flame like a coal. These are some examples of combustion. The substance that undergoes combustion easily and produces heat is known as combustible. Okay, that reacts with oxygen to give heat, okay, to produce heat. That substance is said to be combustible. Okay, different substances catch fire at different temperatures. The lowest temperature at which a substance catches fire is called its ignition temperature. Okay, this we know that different substances catch fire at different temperatures. It's different for like different substances. This is based on its property. Okay, this is based on the property of that substance, that at what temperature it will catch fire. Okay, so lowest temperature at which something catches fire is called its ignition temperature. Okay, necessary conditions for combustion. Now, what actually is essential for combustion to take place? Okay, what is needed for combustion? Ignition temperature be within the axis, means reachable. Okay, ignition temperature must be reachable. Fuel should be combustible, means that fuel should be such a type of fuel that can undergo combustion. Okay, and oxygen, suitable amount of oxygen must be there. Okay, so you do fuel plus oxygen gives heat.
Mom, I think this is called a fire triangle, heat triangle, something, right? The
It's
heat plus
for
fuel plus oxygen.
sorry, I didn't hear you properly.
Yeah, so for a fire, heat, fuel, and oxygen are necessary, right? These are the three main things you need for a fire. I think it's called a fire triangle, heat triangle. I don't know. I'm not sure. These three
Fire
are.
triangle or heat triangle.
Yeah, I think so.
Okay,
It's called a fire triangle.
okay. So yes, this is actually combustion is actually the process of burning. Okay, that's right. Simeon is producing a fire in the background. Okay. So this process, combustion is actually the process of burning. Okay. So that's right. And this is the combustion reaction or burning. Okay. Then we have a flame. What happens? Substances which vaporize during burning.
I didn't finish
Yes,
copying. Can you go back for a minute?
sure, Sunil. Here you go.
Okay.
Sure. Then we have flame. Molten wax rises through the wick and vaporized during burning and forms flame. Okay. So this is the wick of the candle. Okay. This is the wick, and molten flame wax rises through the wick. Okay. Molten wax rises through the wick and vaporize during burning and form flames. Okay. This is flame. All right. It vaporizes in the presence of air, oxygen to produce flames. Okay. Then light a candle and observe its flame carefully. Now introduce a clean glass plate, slide into the flame of the candle. Hold it there with a pair of tongs for about 10 seconds and remove it. What do you observe? A circular blackish ring is formed on the glass plate or slide. It indicates the deposition of unburnt carbon particles present in the luminous zone of the flame. Okay, the flame has
Which
unburned.
is the luminous zone? The outside or the inside?
Um, I think it's the inside.
Like
1 minute.
the thing that's right in the center.
Let me just open this diagram in English. 1 minute. Can you see the luminous zone now? The
Yes, ma'am.
yellow. Yes. So that is the luminous zone. Okay, moderately hot. And non-luminous zone is the blue part, which is the hottest. Okay, that is the most outside part of the flame. Okay. Um, that is the non-luminous zone, which is hottest. The center is moderately hot. And then the dark zone, that is the black part. Okay, most in innermost layer is the least hot. This is the wick and this is the wax candle. Okay. Complete combustion means in the outermost zone, complete combustion is taking place. Okay, the complete burning is taking place. The middle zone, partial combustion is taking place. Okay, which is moderately hot. And the innermost zone has unburned wax vapors. Okay, innermost zone has unburned wax vapors. All right, so this is the structure.
My friend in his school, he had some different type of fire that was created with a chemical that was not oxygen. Oxygen was also used in it, and the teacher said he had to put some kind of, the teacher told him to put some kind of stick into the fire, and the outside got burnt, but the inside was not burnt.
Of the stick.
Yes.
Okay. That sounds interesting. Yes. I've seen some video in which they like make flames
There were
of
two
different
black lines
colors.
on it.
Two black lines on. Okay. They've made different color flames, like the red flame, a purple flame, yellow flame, green flame. They add some chemicals to it
It
to
came
create.
in our stove once I had some science
You're muted, Sunil.
I accidentally put boron on the stove in my science experiment, and when I lit the stove, the flame became green.
You put what?
Boron.
Boron.
Yeah.
Okay. Yes. So when the flame reacts with some chemical, okay, particular kind of chemical,
Sorry,
they
not
change.
boron, it's borax.
It's borax. Okay. So they change color, but that is risky also. If there is a strong chemical, it might cause an explosion too. Sometimes, if it is very reactive.
The fire
Okay?
smelled a funny smell.
A funny smell. I
Yeah,
get it. Yes, because like a
it smelled like eggs.
okay. Yes, because the end product is it's either heat it
Sulfur.
produces or the smell. Yeah. Yes. Okay. So now firefighting. You must have seen or heard of fire breaking out in homes, shops, factories due to the carelessness and faulty equipment. We have learned that there are three essential equipments for combustion. They are fuel, oxygen, and heat. Fire can be controlled by removing one or more of these requirements. It is quite difficult to remove fuel from the site of fire, so fire is extinguished by the following two factors. Okay? Now, this is very interesting and important. Like when a fire breaks out, how do they extinguish it? What do they do to extinguish it? Okay, like it is three things are necessary to for a fire to burn. Okay, fuel, air, and heat. These three components. If you remove one from it, okay, be left with two of them. Okay, which will reduce or like stifle out the fire. Okay, so now it's difficult to remove fuel. So we can extinguish the fire by cutting off the air supply or by cooling the combustible material below its ignition temperature. The supply of air can be stopped by covering the burning solid fuel with soil, sand, and a blanket. With soil, sand, and a blanket. Okay. You must have heard this that people put blankets, like thick blankets and soil on the burning thing,
I've
okay, to
heard
cut
that
off.
they hit it with a blanket, but not that they cover it.
You
They
can
hit
do
it.
both.
Yes, you can do both. You can hit it, you can cover it. That is basically to cut off the air supply. Um, I've also heard that if a person catches fire, okay,
They roll
a
on the
person
ground.
catches fire, they roll on the ground or they roll in a blanket. They are like roll wrapped in a blanket also. Okay, so rolling in the
How
ground
do
is
they roll on the ground?
they rub that suppose the hand catches fire, so they
Yes.
just rub it in the sand like this.
But only in the sand, they can't do it somewhere else, right?
No, they can do it anywhere. It's just like when they hit the fire.
When they hit the fire, that is to cut off the air supply. But I've also heard that to cover them in a blanket Okay, cover them completely in a blanket to cut off the air supply. Okay, and the air supply is cut off, the fire extinguishers. Okay. Then the other thing is by cooling the combustible material below its ignition temperature. Water is a most common fire extinguisher. Water cools the combustible material below its ignition temperature. This is the reason why um, they put water on the fire, okay, because it cools the material below its ignition temperature. This prevents the fire from spreading. Water vapor also surrounds the combustible material, helping in cutting off the supply of air.
You
But
could
water
also
more,
you could also like put water on the fuel so that the like if it's wood, then the wood will be wet and it won't burn.
yes, I mean, that's right. Okay. If a wood is burning, if a wood is on fire, you can put water on it so that it cools down and it stops burning gradually. Okay. Works only when things like wood and paper are on fire because it cools them down. Okay. If electrical equipment is on fire, water may conduct electricity and harm those trying to douse the fire. Okay. You don't, if there's an electric short circuit, a
Don't
fire
put
caused
water on
by,
it.
yes, a fire caused by short circuit, we cannot put water on it. Okay, because then electricity will spread in the whole area along with the fire. Okay. Water is also not suitable for fires involving oil and petrol. Okay, why?
Because
What
they are
is heavier
flammable.
than oil? Yes. Water is heavier than oil, so it sinks below the oil and oil keeps burning on top. For fires involving electrical equipment and inflammable materials like petrol, carbon dioxide is the best extinguisher. Okay. Have you seen these fire extinguisher pumps?
Yes, ma'am. We
Yes.
have we have one or two in our home also.
Okay, that's great. So these are used, okay, to extinguish the fires. Okay, it covers the fire like a blanket. Since the contact between the fuel and oxygen is cut off, fire is controlled. You might have seen red cylinder to get the supply of carbon dioxide. Carbon dioxide is stored at high pressure as a liquid in these cylinders. When released from the cylinder, carbon dioxide expands enormously in volume and cools down. So it brings down the temperature of the fuel. Okay, carbon dioxide is stored in this. Okay, stored at high pressure in liquid form in these cylinders. When we release it, it expands. Okay, the carbon dioxide from the liquid form it expands. Okay, and it covers the fire, okay, and the combustion material, and it brings the temperature down of the fuel, which is burning at high temperature, brings the temperature down. That is why it is an excellent fire extinguisher. Okay, so this is a fire extinguisher. When the knob of the cylinder is opened, soda reacts with acid and pours a mixture of carbon dioxide and water on fire, and fire is extinguished. Okay, this is how it takes place. So we stop here, and from fuel we will continue in the next class. Okay, from fuel we will continue tomorrow. Any questions, anyone? No. Okay.
And tomorrow the test is from chapters 4 to 5, right?
Chapters 4 and 5. Yes, that's one. Okay. Chapters 4 and 5. This is tomorrow. Please prepare well, and I'll meet you guys tomorrow. Bye.
Bye, ma'am. Bye, ma'am. Bye, Sunny.
Bye, ma'am. Bye.
Okay. Bye, guys. Bye.
Bye. Thank you.